work function in solid state physics. The work function, sometimes called work function, is the minimum thermodynamic work needed to remove an electron from a solid to a point in the vacuum immediately outside the solid surface. Here immediately means that the final electron position is far from the surface on the atomic scale, but still too close to the solid to be influenced by ambient electric fields in the vacuum. Work function is not a characteristic of a bulk material, but rather a property of the surface in the material depending on the crystal phase and contamination. The work function W for a given surface is defined by the difference W is equal to minus E phi minus EF, where minus E is the charge on an electron, phi is the electrostatic potential in the vacuum nearby the surface, and EF is the Fermi level electrochemical potential of electrons inside the material. The term minus E phi is the energy of an electron at rest in the vacuum nearby the surface. In practice, one directly controls EF by the voltage applied to the material through electrodes, and the work function is generally a fixed characteristic of the surface material. Consequently, this means that when a voltage is applied to a material, the electrostatic potential phi produced in the vacuum will be somewhat lower than the applied voltage. The difference depending on the work function of the material surface. Rearranging the above equation, 1 as phi is equal to V minus W over E, where V is equal to minus EF over E is the voltage of the material as measured by the voltmeter through an attached electrode relative to an electrical ground that is defined as having zero Fermi level. The fact that phi depends on the material means that the space between two dissimilar conductors will have a built-in electric field when those conductors are in total equilibrium with each other, electrically shorted to each other and with equal temperatures. The work function refers the removal of an electron to a position that is far enough from the surface, many Newton meter, that the force between the electron and its image charge in the surface can be neglected. The electron must also close to the surface compared to the nearest edge of a crystal facet or to any other change in the surface structure.